So in this edition of lecture, we will analyze the topic of total internal reflection and dispersion of light. Earlier we understood what is the refraction, and now we are going to understood what is the total internal reflection. So that is the total internal reflection. It says that when a light travels from denser medium to rare medium, then they deviate away from the normal at the interference, that is angle R is more than angle I. Okay, so when a light travels from the denser medium to rare medium, then they deviate away from the normal at the interference, that is reflection angle is greater than incidence angle. If we keep on increasing the angle of incidence, then at the specific value of angle of incidence, the refracted ray goes in the direction of the interface of both the medium, and angle of refraction become 90 degree. This angle is known as critical angle. So what is the critical angle? In this diagram you can see what is critical angle. That is a 90 degree angle formed due to refraction of light. Due to refraction of light. So that is the incident ray, that is the refracted ray, and when the incident ray or the refracted ray at the 90 degree angle, that is called critical angle. So if we keep on increasing the angle of incidence beyond the critical angle, then the light rays reflect back in the denser medium instead of reflecting in the rare medium. So if we keep increasing the angle of incidence, if the angle of incidence is more and more as compared to the angle of refraction, so what happen? The total internal reflection is happen. Okay, the total internal reflection is happen. So what is total internal reflection? The total internal reflection if we keep on the increasing the angle of incidence, so the total internal reflection is happen. So for example, in diamond, the diamond shines. Why diamond shines so large? Because the angle of incidence of light is more than the angle of reflection. So more and more angle of incidence and less number of angle of reflection, it means the light is going and reflect back from the denser medium instead of refraction. So it goes more and more denser medium rather than goes to the rare medium. Okay, the light is reflect back in the diamond. So diamond shines high due to total internal reflection. In communication technology, the fiber optic cable uses the phenomena of faster and efficient data transfer. Yes, fiber optic data, we use the high speed internet in the fiber optic data cable because and these are faster and efficient data transfer. Why? Because due to the technology of total internal reflection, more and more angle of incidence and less angle of reflection, that is called total internal reflection. An example is fiber optic cable and diamond. What is the dispersion of light by prism? Dr. C.V. Raman in 1938 or 1928, he discovered a spectrum, that is a Raman spectrum, and that is similar to the dispersion of light in a prism. And when the sunlight passes through a glass prism, then the light disperses in 7 colors, and that can be observed on a screen. In a laboratory, white light bulb can be used to get chromatic dispersion, and we must not see towards the sun or reflected sunlight as it may impair our vision or may cause blindness. So in laboratory we use white light as a chromatic dispersion. Okay, and that is yes, this diagram shows the refraction dispersion of light. It describes the dispersion of light. That is a prism, and there is a white chromatic light from a white bulb, and when white light pass through this prism, it deviate and differentiate into the 7 colors. That is a Vibgyor. That is violet, indigo, blue, green, yellow, orange, and red. So that is called the dispersion of light. So dispersion of light is also similar to the Raman spectra, which happened in 1928 by Dr. C.V. Raman. So next topic is power of lens. What is the power of lens? The power of lens is defined as its capacity to diverge or converge the light rays as similar to the magnifying glass. There is a power of lens. It means if a concave and convex lens, they have a capacity of divergence and convergence light rays. A low focal length convex lens will converge the rays near to it, and that rays will bend more. Okay, so in focal length, what is the focal length of convex lens? The low focal length. Due to low focal length in a convex lens, the light is converged, and due to high focal length in a concave lens, the focal length is more, and it will the light is diverged to a different degree. So the focal length is very important for the power of lens. If the focal length is less, it means the lens will be convex and the light is converse, and the focal length is more, it means the light is diverse and the lens is concave lens. So that is the formula of power of lens. How we define the power of lens? That is P equal to 1 by F. That is a P equal to 1 by F. That is the power of lens. F equal to focal length. In convex, the focal length is low, and in concave, the focal length is high. If F is in meter and then P is diopter, so power of lens is always defined in the diopter. Okay, what is the unit of power of lens? That is a diopter. So if generally we can call the number of eye lens, and if focal length of a lens is 2 meter, then its power will be 0.5. So 1 by 2 equal to 0.5. If we can say the focal length is 2 meter, and its power will be what 2. Okay, if P equal to 1 by 2, 2 is a focal length. So 1 by 2 equal to 0.5. So power will be 0.5 diopter. When we go to the eye specialist, he always check first the power of for focal length. If focal length is decreased, he gives us the convex lens, and if the focal length is more, it gives us concave lens for the divergence view. So that is the example. So that is example. Example 10. An eye lens object the light from the infinity on a wall at 25 cm. Find the lens or power of lens. Solution: what is the focal length of lens? That is 25 cm. Okay. So first we need to change centimeter to meter. That is 0.25 meter. And power equal to F, P equal to 1 by F equal to 1 by 0.25. So what is the power of lens? That is 4. That is a 4 diopter. So it is convex lens. So it is what? It is convex lens because the focal length is very less. That is we can call convex lens. In the next edition, we will analyze the different parts of our sensing organs like eye.